Here we are on fundus autofluorescence. Now, the difference in our FAF green and our FAF blue, or FAF green, right, is getting us out to the edge of geographic atrophy. So that's the other corollary or the draw-in. If we're thinking about how does this relate to OCT, FAF green can be really useful for that. FAF blue just is absorbed in the pigments. And so here are 3 different images, and all 3 of those images blown up into the posterior pole. And you can see the quality there, but you can see the edge of the geographic atrophy that actually shows up on FAF green, which is somewhat masked here behind the FAF blue, and is difficult to tell where the outline of it is. Now, this image is so good that there are algorithms that are in process and being developed to actually measure FAF green and compare those over time. So it's a unique measurement tool, and again, a crosswalk. I'll reiterate that again with regards to OCT technology and the possibilities there. This is just a quick comparison of the Spectralis Blue Peak and the Clarus FAF Blue. What I want to highlight about this one is when we get into this image here, this was taken on a prototype of the Clarus. This is not the actual current Clarus that's in this one. And that was early stage. The clarity that comes out with this now is much more reliable than what you're even seeing with Blue Peak. But I wanted to even show you the versions or the iterations before we got out there into the general public. And then here we have our comparisons, right, to the other ultra-wide field devices that are out there, and a comparison to what we've got associated here with our regular retinal photography. So again, traditional retinal photography, we want to know, are we looking at something that's true color? We want to see, does the image quality stand up to what I'm used to having? Or am I looking at something that's going to lead me down a path that maybe isn't the right path diagnostically to be on? So your Topcon, your Clarus, and your Optos are side by side. Now if I blow those 2 up and I look at the quality of the images centrally, you can see the difference where this is really a true retinal camera that we're looking at with the level of detail versus kind of the fogginess and fuzziness around the edges, and even the distortion. This is a non-distorted image. Remember, by the way that the image is taken, nothing gets stretched and spread all over the place. So you don't have to tease out what is normal and what's abnormal within it. FAF green here on the 2 technologies. This, again, is a true size of the image. That's a distorted, slightly distorted size of that image. These are at scale in terms of measurements and pixelation, so you can see that little bit of difference in the 2 of them. And so if you're going to get an algorithm to read that stuff, you've got to have something that is consistently repeatable from a scientific or engineering perspective. I put up geographic atrophy and cataract here because I think this is another important one. If we're looking at cataracts that are moving from 1.5 million to 3 million in the population, that's the piece that we have to keep in consideration with that is that you sometimes are going to run into these patients where it doesn't matter how good your image was, you just can't get a really good light source in there to image the retina. So something like Blue Peak falls down here because Blue Peak is affected by that cataract. Whereas when you are looking at the geographic atrophy that's right here on a FAF green, you don't see any distortion. If I blew that up, that would be just as high a quality. And you can see the image in the Clarus against the VisuCam through that cataract. It's almost as if some of it's not quite as affected by the cataract with the same eye in traditional versus using the LED and the light source that's in here. A little bit more on geographic atrophy, Topcon versus the Clarus. So you can get a little bit more comparison on the colors. You're getting the full field here on the Clarus. You're getting that 45-degree image right here. When we blow those 2 pieces up and we put them at scale against each other, you can see the level of detail that's comparative on these 2. Diabetic ret, again, another example of something in terms of the quality that's there. And then we're all familiar with these eyelashes, which are really still difficult to get out of the way in current ultra-wide field technology. That's what you can do when you can just gently pull down on that eyelid or eyelash and taking these wide field images. There's the images central. And then here are the images one more time blown up. So again, looking at these at scale, looking at these at the level of detail that you want to be able to evaluate as a provider, I think much more significant. And then this last little one, and we had this happen with either our 2nd or 3rd patient that we had with the Clarus. You see a little retinal breakup there? I think it was our 2nd patient that we had. We actually picked up a retinal break that was out in the periphery in an asymptomatic patient while we were doing testing. and going through the initial FDA clinical trial. So you're getting these wide field or ultra wide field images for that purpose, to catch, to look for disease and conditions, and to be able to have a tool that helps you monitor and manage disease over a long period of time, not just hopefully find it, but be able to look at it and gives you tools from a measurement standpoint. These are a couple of pieces. Color, clarity, I'll give them a little bit on comfort. I think the flash is a little bit bright for me, but again, not from a patient perspective and repeatability of the test. So just warning, and we found we really had to warn patients with that, but they don't have to get their face squished, which our patients liked a lot. And when we compared that for patients, they didn't like getting their face squished so much. Many of them would have chosen, other things. So quick questions before I punch on to Sita faster. Any questions I can answer about the Clarus, about our experience with it? Yes?
How far does it go up superior than inferiorly compared to the Oculus?
You'll get, so the superior, what we found when we took superior images, well, we probably got about a 200-degree field superiorly.
Do you have to readjust, two images for that? Or?
Yes. You're always getting two images that are auto-montaged in terms of the device. You can, the tech spec so that you can get a little bit wider than that, but our finding was that with the consistency that we got good field about 200 degrees. Other questions? Yeah.
Dilated pupils give you a slightly larger field or much the same?
Dilated pupils don't necessarily give you a larger field because the image capture is still just as big and you've got overlap. So once you begin to spread those two fields out, even if you were to try to auto-montage them, you're going to have gaps, right, that are in the superior sections. Now, you could take them and widen them out. There is some maneuverability within the device, and then take two larger images, top and bottom, but then you're into 4 images. What we found with the dilated pupil was it just sped up testing time. You were consistently at 2 minutes or less with testing time, and I think we would have gotten faster than that. But that was our initial, workflow in having it on a limited basis to really run the trial. Other questions?
This patient management. If the patient got history of floaters, would
Yes.
you legally can take this photo without BIO?
Could you legally take the photo without BIO if they had a history of floaters or a report of floaters? I'm not a lawyer and I don't play one on TV, but I would probably say do BIO. I'm not going to suggest that you have this and you document the fundus, and for some odd reason, right at the very edge, you missed a little something that was out there. I'd still say BIO the patient with a history of recent onset of floaters. If they're an established history of floaters, that's going to be a clinical call that you make. There's a saying in the US, they did a study, I don't know if you guys have heard of this study, but they did a study with regards to the reason that patients sue for malpractice. And the number one reason that they found that patients sued for malpractice had nothing to do with whether or not they were treated. It had everything to do with whether or not they felt the doctor cared. So there's that adage that people don't know how much, don't care how much you know unless they know how much you care. That's the piece that goes back to it. So there were doctors that were just blatantly not practicing great clinical medicine, but because they cared for the patient was forgiving towards them and allowed them to continue to practice and care for them. Interesting stat. Other questions? Mm-hmm. All right, so that's Clarus in a nutshell. Let me talk to you briefly about Sita, because there's not a ton about Sita. Sita faster. Dane, did you come up with this name? So there's Sita, Sita fast, Sita faster. Sita quickest is yet to come, but it's not here yet. No, Sita faster. So Sita faster is really faster. A couple of quick stats about it, and this is really a very simple slide with a lot of information about it. You can ignore the information to the right just to say, hey, they look the same. They virtually look the same. They're equivalent. Sita fast and Sita faster were equivalent to each other in clinical evaluation. But the key piece are these two stats right here. So you've got 30% quicker, that a Sita faster is quicker than Sita fast by about 30%, and 50% quicker than it is than a traditional Sita algorithm. Now here is the really, really, really nice thing about it. Do you have to rebaseline your patients? Easy answer, no. In an HFA3, Sita fast, Sita faster, and Sita are all talking to each other. So if you've been doing Citas for a long time, or you've been doing Cita fast, and you're worried about, I don't really want to go this route because it's going to mean that I got to rebaseline all those patients, you don't have to worry about that. Its equivalency from a testing standpoint is there, and it's comparable data over time. The other piece is that the testing has been in place since about 2011. And you should also know that with the Clarus has been out there for about 3 years in R&D and clinical development. So that's not a new device on the market either. It's just been a device that refining some of those protocols and algorithms that I was talking about has taken some time. But with Cita Fast, with Cita Faster, you're now looking at a quicker clinical test. With a typical patient who's ready to sit for a visual field, you're about 2 to 2.5 minutes. You're probably closer to 3 minutes on a patient who has a little bit more struggle with taking the test. And it's only available on the 24-2. If you're using a 30-2 on managing glaucoma, first question I would ask you is why? What are you going to catch with those other degrees that are on the other side of the nerve? You're not. There's been no significant clinical study that shows there's any value there. So if you're doing a 30-2, you don't need that for glaucoma detection or management. 24-2 is it. These are comparative over a period of time with your 24-2s and fit into the same algorithm as is already in your HFA3. So if you have an HFA3 now and you are saying, well, how do I get this? Do I have to go buy a whole new unit? I'm going to step out on a ledge here and say it's an upgrade in the software. And I thought I heard, does it cost anything? No. So the software upgrade on the HFA3 for Cita Faster doesn't cost anything for those of you who are already using an HFA3. Okay? Not an HFA2, HFA3. So I promised you a video from India. I don't know if there's any sound on this. If there is, I'll turn it down and talk over it. There is. All right. What you're watching is a 13-year-old running a Cirrus 500 in India for a morning after 10 minutes of training and no language skills in Telugu. And if you have ever spent any time with native Indians who say yes like this, right? This was really interesting to watch as to whether this would work at first. So he's sitting there on this device. Do you see the green star? And they do this, and then they move off. Well, could you hold your head still while and then somebody would say that in Telugu, and then they do this as they walk out. Please hold your head still. And they keep doing this. And it was on and on and on. So we had to really play with the language a little bit. But that wasn't a technical issue. That was a communication issue. I put this up here because some of us are concerned about or scared in terms of using technology. He ran this for a whole morning on black cataracts that people were effectively completely blind in the one eye and got images of the retina and the nerve that techs of mine working in my office for years had gotten. So I put this all up there to say, and the reason we use this is because the first time that we used it, we found 50 cataracts that we would have done the wrong eye on out of 400 because the macula had problems that we couldn't see with the BIO or direct. So the OCT was invaluable in getting behind there and capturing some of the information that was in the back. But I put him up here and wanted to show you this because if you're scared of OCT or even how to run an OCT, get your local 13-year-old and have them teach you. So with that, OCTA. And I'm just going to touch on a couple of quick things here with OCTA. Now, we have been running OCTA since early October of 2016. The unique thing about OCTA and what you're looking at all in white here is anything that's in white on this particular image is the movement or the change in the erythrocyte through the vessels. And this is not depth arranged, so you can set this at different depths in the retina, and you can actually color code those depths, which I'll show you in a moment, so that you know which layer that vascularization is occurring at. Now, what's unique about this is on the other side, there's another image that's actually your structural map, which is your en face image, so you can dive into the tomogram. You can get an angiogram and a tomogram of the retina at the same time and take a look at these pieces, and I will tell you that this has grabbed patients' attention more than any other image or any other device that we've brought in, because you can take this image And you can overlay it on a black and white fundus image and pop it up on your screen, and they know what they're looking at in a heartbeat. And when I tell them that same capillary plexus is in your kidneys, they go, so would you see if something was going on in my kidneys? I said, we'd have very strong suspicion if something's there. So they immediately make the connection with regards to these devices and what we see inside. Just a little bit about the scan and its acquisition. This is a great slide, though, that shows the different areas of the different maps. So you can see on this slide, you've got this red square, the green square, and the blue square that are going around the images. You're at superficial retina, which if you saw this on a slice is through the superficial retina here in the tomogram. If you look at the second one there, it's your deep retinal map and then an avascular retinal map. I bring that up because this is what's used when we look at this color depth imaging map. So if you saw blue in here, it's a, hey, watch out for what you're seeing. It doesn't mean they have something. There can be another reason why blood vessels are in the avascular zone, and it's not anything to do with new blood vessel growth in the avascular zone. It can be due to structural changes, due to stuff happening underneath or up above, so be aware of that. And the other one I would draw your attention to is when you think of your OCT, don't diagnose red disease. Red disease is not named after Joe Redner. That was bad, sorry, Joe. There we go. All right. No, but so red disease is a condition that we refer to in the US that's based on chasing the algorithm's diagnosis. The algorithm telling you that there's a problem here in the nerve. So you look at that and you go, well, there's glaucoma. Okay? That's not an active disease. That's just meant to draw your attention that there's a differentiation from normal. And you could have other conditions which look completely normal and should be red. Realize that too. We could go into a whole course on OCT and really reading and diving into OCT at deep levels. We do a lot of posterior segment in the US, so that's why I'm going there, but just realize that. Blue disease would be the same thing here. So in blue disease, if you have pathology, there's places where the pathology is real and there's places where the pathology is not real. Now I'll tell you a clinical case that we had with regards to when we started using OCTA.